Okay, so we left off on modeling this little topography and then making a box around it in order to make like a little formwork that we can CNC route and cast concrete into. So the next step to take with this box is to set up a RhinoCAM file. Now the first thing I'm going to do, I already have my model scaled, but for RhinoCAM to work properly, we really kind of have to have a clean file. So I would actually go ahead and save this file as something else. And then I can go back and I'm going to go over to my layers and just delete all the layers that I'm not using. So I'll select all those layers, right click and go delete layer. Select yes to all. So there's obviously geometry on those other layers, we don't need them anymore. And then just to double check that there's no kind of weird extra stuff in our file, we can type in select all and zoom selected. And you can see that there's only this geometry in our file. Okay, so the next step to take would be to go ahead and start setting up the RhinoCAM file. Now the reason this is a separate video, I should have said originally, is you will need to use a lab computer in order to do this part of the tutorial because you don't have RhinoCAM on your own computer. But if you go to any computer in the lab or one of the computers at the end of the hall, you'll be able to do a RhinoCAM setup. So when you open your file on one of those lab computers, you should see at the top menu RhinoCAM 2018 or 2019. I'm going to select that and I'm going to select mill. Now the other thing that'll be really useful for CNC RhinoCAM setup is to use the software Guidebook. Now this is the kind of comprehensive set of tutorials that were created to outline how to go between one software and another and so on. If you go to kapla.arizona.edu and search in the command line software Guidebook, you should find this page student software, and somewhere in the middle it says School of Architecture Software Guidebook. And we'll just click on the box link, and this will take you to a PDF, so you can download this file as well. And I'm going to go back to the start, first page. And then on page 2 you'll see the contents. This is all the kind of little tutorials that you can find in this PDF. And under modeling, we'll find one that says CNC router RhinoCAM. And I'm going to click on that button, and it should take me to where there's a tutorial for setting up a RhinoCAM file. So we're gonna use this just to get our settings correct, and then we'll do something a little bit different once we actually generate our toolpath and so on. Like I said, the first thing would be to load RhinoCAM. So we go to RhinoCAM, press mill, and you should see these two windows appear. So we have the machining browser and we have the machining objects. The first thing to do will be to set up the post file. So in the machining browser, there's a button that says post. If I click on that, you may or may not find in this current post processor drop-down that one of the options is Shop, Sabre, WinCNC, UA. But that's what it needs to be. So if you don't see that in your drop-down menu, you need to actually go down here where it says folder where post processor is located. Click on the little 3-dot button. And in the PDF, let me zoom in a little bit. This is the address where that post processor is located. So you will also need to be on a computer that's connected to the internet here. because this file is on our server. So if you go to network capla-student.catnet.arizona.edu, MATLAB, and then RhinoCAM, you'll find a folder called postprocessor. And once you've loaded that folder, you should be able to select ShopSaber WinCNC UA. The last thing we need to set here is the posted file extension. So from this drop-down menu, we want to set that to .tap. Now these two things basically establish what kind of file will be created when we're done. When we're done modeling and setting up our RhinoCAM file, we need to generate what's called a GCode file. And the GCode file is what the router will actually read in order to fabricate our object. So ShopSaber WinCNC and .tap. And then I'll click OK. The next step would be to set up what's called a stock box. Or no, I'm sorry. The next step is to find the tool library. The other window that should have opened when you opened RhinoCAM is the machining objects window. And you can see in here, if you don't have tools loaded, what you need to do is actually load the tool library. Now this could also be because up in the top left, if you have your RhinoCAM set to turn rather than mill, make sure just click that button until it says mill, and you might find that the tool library will load. In my case, I don't have the tool library, so I would click on this little button with the blue arrow and the little floppy disk, and I need to navigate again to the same location. In order to do that, I can actually just go in my web browser, or I'm sorry, in a file browser, and I'll type in this address. So capla-student.catnet.arizona.edu /MATLAB/RhinoCAM. Okay, and then we can go ahead, once we've typed that in, so that's what it should look like, //capla-student.catnet.arizona.edu. We can go ahead and copy that address and paste it in this dialog where it says open. I'm sorry, paste it in this line, press enter. And so this is where all those files are located. I'll go into the folder tool library. And I actually want to open this one that says RhinoCAM Tools 1.16.vkb. So not the one that's titled new. And you'll see this one actually has a newer save date. So I'll click on that one, click open. You should get this dialog that the tools were loaded, and you should also see all these tools loaded in the machining objects window. Okay, so, once we have our tool library loaded, the next thing would be to set up the stock box. Now, like I mentioned in the last tutorial, our stock box is going to be, go up here to where it says stock, click the drop down, select box, stock, and you want to enter 7.5 by 7.5 by 2 for the length, width, and height. And if you have no extra stuff in your Rhino file, it should actually automatically figure out those dimensions for you. So I'll click OK. Now also just to kind of show you how to do this part, let's say our geometry was misaligned or something like that. Let me show you all this. So I'm just going to move this geometry out of the way to show you what I'm talking about. In order to align our stock box to our geometry, we can also use this button Align up here in the machining browser. Click on Align, click on Align Stock. And what this will do is once you've created a stock box, it will allow you to position your part inside that box. So for example, if you had a stock box that was a lot larger or different than the dimensions of your part, you could align it in a certain spot to that geometry. So ours is the same size, so we can just click top, center, and it will align our stock box to the part. And the other thing we would then need to do is establish the 0. So you always want to have the 0, 0, or the origin of your file at the corner of your stock box, because that's actually how you locate, when you go to route something, where the bit is and where the router needs to mill into your material. So again, we'll go to Align, Set World CS, and here we can choose Set to Stock Box. We always want to zero the Z dimension to the lowest point, because what we'll actually do is zero the router to its own bed, to the router bed. And that will help us ensure that we don't end up routing into the bed of the CNC router. The other thing we want to select here is the X and Y 0, and we're going to choose southwest. In other words, the corner that's nearest us. So again, that when we go on the router, we can figure out if we line up our bit to one of the corners of our stock box, that it'll mill in the right position. So I'll click lowest Z, southwest, and click OK. And after a second, you should see that our part has moved back to the origin of the file, or the 0, 0 point. Okay, so once we've set up all those things, we would actually go ahead and generate a toolpath. Now, I just want to point out that for most of the routing that you might do on the router, this tutorial will make more sense. So this tutorial is going to tell you how to set up what's called a roughing pass. And a roughing pass is essentially designed to use a large bit and remove a lot of material really quickly, like so, and you can actually do simulations. We'll do that in a second. So a roughing pass is basically designed to remove the material that you don't need from your part quickly, and then you would typically set up another toolpath called a finishing pass. And the finishing pass is designed to route directly to the finished surface of your part and produce like a much nicer finish, like you see here. Now, because what we're doing is actually like a stepped topography, all the individual layers are actually flat, and we're routing out of foam rather than wood or plastic or something harder than foam. We're going to do our setup a little bit differently. So I'm going to go over to Machining Browser. I'll click on Setup, and under Machining Operations, there's a drop-down. And in here, we're going to choose 3-axis. So these are the toolpaths that were shown in the PDF tutorial. We're going to choose Clear Flats. So once again, this is a setup that's kind of specific to like a stepped topography model. Once we select Clear Flats, it's going to open this dialog, and it's going to ask us for a whole bunch of information about how that toolpath should be set up. And this stuff is there's a lot in common with this and other toolpath setups. The first thing that we need to establish is what's called the control geometry, and what that means is that will define where our toolpath will be generated in the X and Y dimensions. So down here, I'm going to choose Select Flat Area Regions. And I'm going to orbit my model, so I'm looking at the bottom. And what I need is, I need this rectangle, right? So even though my box is larger, I actually only want to mill on the inside where my topography is, right? I want to keep those walls in place for my formwork. So I'll orbit to underneath, click on this bottom contour surface, and click Enter. And you'll see an orange line should be created. You should see just one line So if you don't see one line, you'll have to maybe make your own rectangle and set the control geometry to that rectangle. And this orange line is basically how RhinoCAM knows where it's allowed to cut and where it isn't. So the next part of the tutorial is to choose a tool. The tool is actually the router bit that you're using. So this tool library is actually the collection of router bits that we have here to run on our router. And there's a few pieces of information that are important here. The first piece is going to be the number. So that's actually how they're organized downstairs in the shop. So that's how you identify which bit you want to put on the router. The next bit of information is where it will say flat mill, or it'll say ball nose, or ball mill. And that is exactly what it sounds like. If you double click on any of these bits, you'll see like all the information for that bit. And a flat mill literally just means it has a flat bottom, and a ball nose means it has a ball bottom, or like a spherical bottom. So like in the PDF tutorial, we used a flat mill, large bit, to do the roughing pass, right, to remove the material fast. And then we use a smaller ball nose bit, which could contour better to this type of geometry, to do our finishing pass, to get a nicer resolution on the finish pass. Now, most of the time, you'll want to choose a bit that is as large as possible to cut what you want to cut, and as short as possible to cut what you want to cut. So if we look at the third bit of information in each title, you can see that those are different numbers, and these are descending order of the diameter of each bit. So 0.75 is obviously 3/4, and they go all the way down to 1/8 of an inch. And for the most part, you'll want to stay up here and use, again, like the largest bit you can. Now, on our part, we actually need to kind of choose our bit based on like some of the smaller little pockets that we would need to get the router bit into. So for example, back here, we probably won't be able to get into that with the router bit, but like right here and right here, we need to choose a router bit that's small enough that it can actually fit inside that little hole. Otherwise, if we choose a really big bit, it'll just ignore that. So we could go down to one of the smaller bits. The other bit of information would be, if we look at the comments, so in any one of these bits, you'll see in the comments section there is some information about what materials to cut with this router bit. So they're all kind of designed for different materials. What's really important is not to use a foam-only bit on wood or plastic, because you can potentially break the bit. But for a foam routing job like this one, we can actually use almost any bit. So we could also go down, let's look at the 3/8. So if we're looking for a 3/8 inch, we also want a flat mill, right? Because again, we're routing to a step topography with flat surfaces. And if we click on these bits, or double click I should say, the final bit of information will be the tool length. Now the tool length is important because depending, like in our case, how deep you want to route into something, you may have to worry about whether or not the machine is going to run into the top of your block while the bit is actually down here cutting on the surface. So again, we could look through these 3/8 inch flat mills, see if any of them, they're actually all 2 inches, so it doesn't matter. Okay, so we're going to choose number 11, 3/8 inch flat mill, 2 inches long, and click OK. The next step, once we've selected our bit, will be to go to Feeds and Speeds. And in here, we're setting the speed that the router will move, the speed that it will spin in the spindle, and how fast it will like enter and exit a cut path or tool path. The only thing you have to do here is each time you select a new tool, you just go to Feeds and Speeds and you click Load from Tool. you may or may not see the numbers change, but those numbers are set by the router bit that you choose. So just click Load from Tool. Then we can move on to Clearance Plane. So this will define like how far the router rises between different toolpaths. So for example, sometimes it'll cut all the way down in one area, move up, and then cut all the way down in another area. And we want to make sure that when it goes from cutting in one area to another, it doesn't run into like part of our geometry that we want to keep. Most of the time you can leave this on automatic. You can also set it to a specific number to reach if you want to be extra careful, or you can set it to a lower number if you want to save time and don't think this is a problem. For now, we're just going to leave it on automatic, and then we'll go to cut parameters. Now in cut parameters, we always want to set the in tool and out tool to 0.01. This defines the resolution by which the router will turn like a curve into a series of points. So everything you do on the router needs to be turned into like individual points that the router is going to move between. The only thing this number will affect is how quickly your toolpath will be generated. So as it's calculating, we wanted this number to be relatively low so that it can calculate a lot faster. The other thing that's important here is the stock option. So again, if we look at the diagram, you can see the stock. This number defines like how far away from our finished geometry the router will go on this toolpath. So again, because we're using foam and we're cutting right to our finished surface, we actually want to set this number to 0. We want to cut right on the finished surface. Normally with a roughing pass, you would leave that number at a larger number and then set it to 0 on your finishing pass. The other thing that's important to define here is the step over control down at the bottom. So again, like in this diagram, the step over is like the distance the router will move as it's cutting like subsequent paths. So like on this flat surface, it's going to go in and clear that whole flat area in like subsequent paths. And this is the distance apart that those paths will be. Usually you want to set this to about 25%. That's the diameter of the bit. So 25% of a 3/8 inch bit. You can go up to, on foam, you can go up to maybe 40%. And you never want to exceed 50%. Because the router is always, the router only spins one direction, which means that it's only ever cutting with half of the bit. It's only ever cutting with half of the edge of the bit. So you never want to exceed 50% on the step over. The next option is Z Containment. So in here also we could set a bottom and a top. One thing that this is useful for is if you have a geometry where you're not sure if it's a closed poly surface or you're not sure if there might be holes in it, it's useful to set like a bottom limit to your toolpath. So again, even though we're routing down into a form, if I change to wireframe, you can see we're not going to route anywhere near the bottom. So if we check the bottom, click on the little cursor, and then snap to, the bottom edge of our lowest contour, which I'm sorry would actually be over here. So this little red plane defines like the lowest that this toolpath can go as it's cutting. So in order to just be safe and make sure we're not going to cut into the bed, that we won't have any errors in our geometry, we can set a bottom limit. The next option is Engage Retract. Usually you won't have to mess with this. The one thing you may find is that the router, it generates this tiny little line when it's entering or exiting a toolpath. And sometimes you want to actually turn this off because that tiny little entrance or exit line is cutting through a piece of material you don't want it to cut through. All you have to do is go in here and set all these values to 0, and then it won't do like an Engage Retract. Okay, so now we're completely set up on our clear flat tops. I can go down here and click Generate. it should take a second, and then we should have a new toolpath show up under our setup over here in the machining browser. Now down in the left hand or bottom of the machining browser, there's all these little icons. The first one is stock visibility. So that's how we turn on and off our stock box, so we can see the geometry relative to the stock. And then the other option that we like to use is toolpath visibility. So if I click on toolpath visibility, and then I select my toolpath that I just generated, it'll actually display in my viewport where the router is going to go as it's cutting. So once again, these vertical lines are the engage and retract lines, red and yellow. So that's where the router is going down or moving up. The blue lines are where it's actually cutting, and the red lines that are horizontal are moving from one cut to the next. So that's our clearance plane. That's where we would want to make sure that those lines are all above any of the geometry we want to keep. Now, the next thing to do each time you generate a new toolpath is to actually simulate that toolpath. This is a really useful thing that RhinoCAM will do. So I'm going to uncheck toolpath visibility. Again, with clear flat tops selected, I'll right-click and click Simulate. And then you can see in the top of the machining browser, I've changed from the Program tab to the Simulate tab. And it will display a little animation of how the router is actually going to go and cut my block out. Now, one of the important things, or important reasons to do this is, again, to double check that you're, if you choose a bit that's too short and the machine might run into the stock box as it's cutting, it will display that when you're doing a simulation. But also, it'll just give you a good idea of what the geometry is really going to look like once it's been milled with this size bit and with these settings. So, for example, if we look in some of the corners, because of the diameter of the bit, we're not getting a clean cut between that contour and the outside wall, which is fine. We're just going to have to live with that. So you can see that happens everywhere where we're meeting a certain angle that our bit just can't reach into. And again, so this pocket's too small, the router just won't go there. Okay, so that's essentially the toolpath setup. When you're done, there's a couple bits of information you can look at. One is if you go back to Setup, right-click, and go to Information, it will give you an estimate of how long it will take to route this toolpath. This number is usually about a third of what it actually takes on the router because of the limits we have set on our router. The other thing that we want to do would be to generate or to post that G-code file. So if we right-click on Setup, so make sure you have Setup selected, right-click and then go to where it says Post. It will ask you where you want to save a certain file. I can just save mine on the desktop, rename it to whatever you want to name it to. Again, it should automatically change to .tap. You should automatically have this ShopSaber WinCNC post-processor loaded. And when you click the button, you'll find that a notepad file has opened, or a text file. So this is the actual G-code that will run the router, that will tell the router where to cut and so on. In this file, we want to search for a couple of different things, just in order to double check that our file is set up in the correct way. So if I hit Control F on the keyboard, I think you can also go to Edit, Find. We want to search for, first of all, Z-, and click Find Next, and you should have no values that show up with a Z-. So again, this is the reason that we zero to the bottom of the block. And if you look, each one of these lines represents a point, a coordinate point in space. And so if we had any numbers that were negative in the Z-axis, we would know that that means that the router is going to go below the bed. It's going to cut into the bit. So in order to make sure that that doesn't happen, we want to search for Z- in the G-code file. And then I'll hit Control F one more time. The other thing we want to search for is M5. And M5 basically means that that's a code that means that the router is going to stop. So every time the router reaches an M5 in the code line, it will stop running. And when you have a file that's set up like the PDF tutorial with 2 different toolpaths and 2 different bits, router bits for each of those toolpaths, you'll find that M5 will appear, and it'll give you, a new tool number, and it'll tell you right there, right after the M5. And that's how you know when you have to change the bit and what to change the bit to. So that's just to check that our file is set up in the right way, that we have all the tool changes we want. And that should be it. So once you're done with that, you can click Close. And then if you save this file, once you've done your RhinoCAM setup, so again, I'll just click Save. It should remember all your RhinoCAM settings, and that'll be the file that you'll want to upload onto D2L for this part of the CNC router workshop. All right, that's it.